So I
Okay.
was looking deeper
Mm-hmm.
into the algorithm that Omar came up with. Uh,
Mm-hmm.
you could put in any amount you want, right? Any amount of books you want to arrange, right? So,
Mm-hmm.
so by his logic, right, it's SLM. If I have small, large, medium, right?
Right.
And
Mm-hmm.
in each section, that means we'll have one out of place, right? So,
Mm-hmm.
and
If,
then
if, if, if if what? Repeat that part again.
in each section, it will have one out of place.
In each section.
Wait, never mind.
No, no. What? Up to what he
No,
said.
I think he was talking about like if you had LSM, like if you
Uh-huh.
had one. But then I realized, like I was thinking the same thing too, 'cause I thought I was wrong. But then
Mm-hmm.
one is not technically an even number. So if you divide integer division that by two and add one is still one.
Yeah.
So then you have one error, which would be one minimal swap. So it works with one.
Okay. All right. Yeah. Right. Yeah. 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 So don't listen. Don't overthink. Right. We have let's because Omar's approach is nice and fast and quick. Let's see if we could code that. Right. Because we still have some counting to do here according to the string. Okay. So let's see if we could code that, and then we will see if we could go the swap approach to validate it. All right. The swap approach is harder. Um. Let's see if we have enough time. Okay, so we want stdio.h. mm, So this is C files for what? Supplementary classes. Where is you guys are lower six? Okay, what's the name of this? What's the name of the question? Arranging books. Right? ARR underscore books. That's okay. So the first thing that we want to do is we want to say um cha was the book arrangement, right? Book B underscore ARR. Okay, for our book arrangement. Let's say we could have up to 1,000 books. All right. What do we want to do with this? We want to get the user to enter the way that books are arranged, right? So enter the way that books are arranged, and we put large LMS only. So I think everybody would have had up to here. All right, we have fgets, stdin. No, why am I using fgets? Yeah, yes, std gets stdin, comma 1,000, comma sorry. All right, so fgets is like gets, except that it will save the backslash n. I'll use it here to see that we could save the values the same way, right? So if we say printf and we say printf percent sign s, okay, you could print out your book arrangement and it will have the same the same order as to what you put in. So if we have L M S S S L L L M S M S M S, okay, we get back the same thing. F gets same thing. The only difference is right, and this is like the same thing. The only difference is that F gets stores the backslash n. So if it is that you have an array and we have L, M, L, M, S, S, L, M, it's going to save that backslash n here. So you have to strip that backslash n from the F gets input if you want the pure string. Okay? How could we do that? Did I go through, I went through some string functions with you guys, right? You all know about strlen?
Yes, sir.
Right. So I spoke to you all about strlen. So we can go strlen, right? We could say b underscore arr at position strlen for b underscore arr, right? -1, which is the last position, and make that equal to a backslash 0. So what is this? Strips the backslash n character from the string entered. Okay, so again, it doesn't change anything. If we have LMSS, LMS, we have LMSS, LMS. Notice that last time I printed out without it being here. There was an extra line between these two things. If you don't believe me, watch and see. I'm going to take off the stripping of the backslash n and run it. LMSS, LMS. You notice that we have that extra space there. And with it, we don't have that extra space. That's all that this does. Okay? What it says is at the last character of the array, turn it to backslash 0 so that that's where the string ends. All right? So we have the way that the books are arranged. And we want to have some variables. We know that we want to keep a count of how many L's, how many M's, and how many S's. So we could say L underscore count is equal to M underscore count. Is equal to M underscore count, which is equal to S underscore count, which is equal to 0. So this is the count for all of the characters. All right, this is the array to store the book order. Okay, so we enter the way that the books are arranged, LMS only. So we get the book, right? Ask for the book. Get the book. And strip the backslash n. And now what do we want to do? Omar, you're the man in charge. What are we doing from here? We have to actually.
Wait, I'm gonna need the count for the errors as well.
Huh?
The count for the errors.
Right. So we have an e count. Right? E count is equal to 0. Why is it on its own line? Because right, but we could have put it there too. So this is the error count.
Well, honestly, sir, as I was saying, I'm not sure about the coding aspect because I'm not sure how you're going to like verify letters.
Omar, that's why we're here. We're gonna think it through. As we talk it through, we do the code. Right? So we go back to what Omar was saying, and once we know, right, that how much L's, how much S's, and how much M's we're supposed to have, we could now know when something is in an error range. So we essentially running through it twice. We're running through it the first time to find out how many L's, M's, and S's we have. Okay? So we could say traverse to count total L's, M's, and S's. Anybody is not with me? so far in terms of what we're doing, we haven't deviated. We haven't deviated from what we were doing in either one of the plans that we made to solve this. Because in either case, we need to know how much L's, M's, and S's we have. How can I count the amount of L's, M, and S's? I use a for loop, and I say for what? For, this is an integer, sorry. This is an integer, and we could have a counter I. So we could say for I is equal to 0. For I is equal to 0. I is less than strlen, the string length of what? I is equal less than the string length of b underscore array. Really and truly, I should include string.h here. And then I go I plus plus. And so what do we want to do from here? We want to use some if statements to count whether it's an L and M1 S. So I can say if b underscore array at position I is equal to an M, right? Or we could make arrangements for or right? What do I want to do if it's a capital M or a common M? Okay, if it's a capital M or a common M, we can say we could say M underscore count plus plus. Else, if, and because I'm lazy, I'm just gonna copy this and change this to what? Change this to L or L. Right? L count. Right? Else if it's equal to an S or an S, common or capital S, then we will carry up S count by plus plus. All right? And then if we have anything else, then we could consider this an error. So you could say printf, right? Invalid input found, program will stop. You go get char so that the screen output will pause, and then you go exit 0, the program will stop. Right? Exit the program. So if it is that at any point in time, right, int L count is equal to M count is equal to S count is equal to 0, Y is, yeah, I would have had to declare them and then do that. I'll just go equal to 0, comma, equal to 0, comma, right? And I left out a semicolon here. No, I did not. What is it telling me here? Oh, I forgot a semicolon up here. My bad. Right, so if it is that I enter some input and I enter LMS, LMSS, LMG, it said invalid input found, program will stop. Why? Because it find that G inside of there. This is supposed to be LMS only. So I got the invalid input and it's stopped. If it is that I only have LMSs, well, it should still stop because we don't have anything else. LMSS, LMMLS, MMSSLL. It printed out what we put in as valid input. Everybody good so far?
Yes, sir. Yes, sir.
Yes, sir.
All right. Good. So what is the next step? The next step is once we know how much M's we have, how much L's we have, how much S's we have, we can now count the amount of errors that we have. Because if within the first M values, if within the first L values of the array, we don't see an L, then we can count that as an error. Agreed? The same thing for M's and S's. According to what um, Omar said we should do. Not so, Omar. This is what you said. Right? So within the first L spaces, if we see anything that is not an L, we count that as an error. Within the next M spaces, we should count that as an error. And within the S spaces remaining, we count that as an error. So let's see if we could get a loop to represent those M, L's, and S's. So we say check the first list L spaces and see how many values are not L's in those spaces. Okay. So just to count out, just to print out for the sake of the user, right? We could print out %d L's L, M's, and S's. All right, and what this gives us here is this will give us the L count, the L count, comma, M underscore count, comma, S underscore count. Save. So this is just some output to the user. Tell the user how much of each value was found. The specification didn't ask for that, but it's for us as the programmer, right? So we say LMS, LMS, LM, SMS, LLMS, LMS. So we have 6 L's, 6 M's, and 7 S's in what I've entered here. Okay, anybody want to do a quick count and see if that's correct? 1, 2, 3, 4, 5, 6 L's, right? Once the L's correct, I think everything should be correct. 1, 2, 3, 4, 5, 6, 7 S's. So far it tells us what. So what does that now mean? What does that now mean for us in terms of being able to find the errors? Check the first L spaces and see how many values are not L's in those spaces. So we could say for I is equal to 0, semicolon, right? I is less than L underscore count. So for I is equal to 0, I is less than L underscore count, semicolon, I plus plus. Inside of this for loop, we say if B underscore array at position I, if B underscore array at position I is unequal to the character L, or B underscore array at position I is unequal to the character L, what do we want to do? We want to say error E underscore count plus plus, right? So what did we see? For every value in the L spaces, if the character is not an L, count it as an error. And at the end of it, we could say printf and sign the percent sign the L's found out of place /n. So let's just see how much L's are out of place. Okay? So we enter L, M, S, L, L, M, S, M, S, S, L, L, M. We say we found 5 L's. And I did some foolishness there because I forgot to put the E count up to this place, right? This is just a test there. The E count is supposed to count all characters out of place, but I just want to make sure that it's working for the L's. All right, so we say L, M, S, S, L, L, M, S, S, L, L, M, S, S, S. Do we have 5 L's out of place? I have put /n. Right? How much L's we have? 5 L's found. So we had 1, 2, 3, 5 L's found, and we had 5 L's out of place. That doesn't seem correct. 1, 2, 3, 4, 5. That can't be correct at all. Right? So something is wrong there because we're starting from position 1. Really and truly, we should have 1, 2, 3, 4, 5. 3 L's out of place. Okay? Watching this here to see if I made an error. So we're starting at the 0 position.
Does it have any way to make like a barrier between 0 and 4? So like
a barrier between 0
and 4. So it would
yeah,
check
in
the first 5 digits.
Yeah, this is what the for loop is. The L count is 5. So for I is equal to 0, I is less than 5 is the barrier between 0 and 4. Understood?
Yeah.
Right. So the only thing is for some reason I have an error with the amount of L's found out of place here. So I just want to, if B underscore array at position I is equal to L or equal to L, right? So it should only come up for this, and this.
So maybe if you have like if it's equal to the S or the, you know, if it might do there.
Oh, what?
Like instead of saying
what you mean? Instead of saying n equal to L, say if it's equal to S or M.
yeah, so you could try that. So maybe that will work.
Okay. I mean, it seemed like more work to me, and I want to go the programmer route of figuring out, well, where I went wrong with this, right? Just allow me first to, hold on, allow me first to just troubleshoot this specific this specific instance. I'm going to print out the first file. Printf. Right. Printf %sign C %sign D. I like to put like asterisks around my debug data so that I know that it's actual debug data. underscore ERR at position I, and E underscore count. So I will see that the E count is actually rising as it changes. You all understand what I did, right?
Yeah.
So I'm going to, yeah. So I should see it actually. So let me see. LMS, LMS, LLSS, LMMSS. I think I know why. This should be a and here, not a or. So this is actually doing the correct thing. There should be an and here. Because you want it to be unequal to either one of the L's. All right? See, L, M, S, L, L, M, S, S, M, S, L. Right, so it doesn't count it for the L's. So we have 4 L's, and 2 of the L's are out of place. Sorry about that. Okay, had a hard vacation, right? Sometimes we make mistakes. So it has to be that it's unequal to a capital L and it's unequal to a common L. Once it's unequal to both of them, then we will count it as an error. So we have 2 L's found out of place. You all understand what I did here, right?
Oh, I understand where it went wrong. It was because it was working as, since it had the capital L, that would have been unequal to the common L, so it would have counted that as an error.
Yes.
Okay.
So we have 3 L's. So notice, however, we have something to know. Now the first for loop went the first for loop went from position 0 to position 4, which is less than the L count. Right? So this is less than the L count. Where in the array should I start counting for the range for the M's? The range for the M's needs to start at position 5. So the counter, the I, will start at L count, and it will go until, right, I is less than L count plus M count. You understand how I get the second range for the second, to now check to see the errors for the M's?
Because L is 5.
Right, so we're starting at position 5, and we're going until, we're going for, up until 5, 6, 7, 8, because position 9 would indicate the start of the S's. Understood? This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we know that the L's, we have 5 L's, so we took the first 1, 2, 3, 4, 5 positions, and we know that we have 3 L's out of place here. Next, we want to take, starting from position M, which is where L count would have been, and we go in for the next 4. So we go in 1, 2, 3, 4. And any M's out of place, we know that we have 2 M's out of place. And then we go in from position L count plus M count, which will be position 9, up until L count plus M count plus S count, or the size of the array, minus 1. You all understand how I got my ranges here now? Because I have to continue on from the previous range. Nobody's saying yes. Nobody just.
Yes, sir.
So, well, if you do it like in sequence, say, then the I value should be already at the L count, and so we would add, and then
Yes and no. Yes, it should be. But I really don't recommend unless you have a specific counter, because in some instances it might work, but in some instances this I value gets discarded after completing the loop. I'm not 100% sure if it happens in C, but in some languages it does, that after you utilize the counter, the value gets discarded. So I've gotten in the habit of not utilizing that. If you understand what I'm saying.
yes, sir.
So I do know for a fact, however, that if I do go on with my loop as I explained before, I could copy and paste, and I could say check that the next M spaces, check the next M spaces and see how many values are not M's in those spaces. I have my value for L count already sorted out, and I have my value for L count plus M count sorted out. You could work with the I, but I just say I'm not 100% sure. So I'm 100% sure about these values here. So I'll roll with these values. And then I could do the same for the S spaces. Check the next S spaces and see how many values are not S's in those spaces. So for I is equal to, right, L count, and you start with what you had ended with, L count plus M count. And I is less than L count plus M count plus S count. And for a fact that I know that at the end of it, I could see printf, there are %b values out of position, and those values would be the E count. So let's check it and see if we get those values. Oops.
Yeah, but change the letters on the F statements.
Hmm?
Yeah, change the letters on the F statements.
Oh, right. Right. Yes, thank you. So we have to change this to an M, change this to an M, change this to an S, change this to an S.
So on your underscore, so
I'm an underscore. Oh, right. So or else it would not have compiled. So enter the way that books are arranged. Let's go small. Let's go SS M L M S L L. Okay. So we have 3 L's, we have 2 M's, and we have 3 S's. So we know that this one is out of position, this one is out of position, this one is out of position. This one is out of position, this one is in position, this one is in position, out of position, out of position. So according to our OMA theory that we're working with, because it's even, it would be the amount of things out of position divided by 2 would be the amount of spaces, amount of swaps that we would need. OMA, is that correct?
yeah, for even numbers.
Right. So for 6 values out of position, we would have 3 values. We would have 3 values. We would have to make 3 swaps to get those values back. And we really should have worked it through, but we trust OMA. Okay, we trust OMA. So we say if what? If E count if E count
If
mod 2,
econ mod 2 is n equal to 0,
okay, n equal to 0.
then the number of swaps would be e count
Right.
e count divided by 2 plus 1. And that would be
Right. So
odd.
if E count mod 2 is equal to 0, we are going to put swaps to be equal to
E count
count
mod 2 plus 1. Not mod,
mod 2 is
divided by 2.
divided.
Divided by 2,
Okay,
sorry. My head just,
plus 1.
yeah.
No problem. Else
As e count
swaps is equal to
e count divided by 2.
divided by 2.
Yeah, forget the underscore.
Oh, all right. So we have swaps is equal to E count divided by 2, and then we could simply print out printf. We will need percent sign D swaps.
Wait, we didn't have to make swaps a variable at the start.
Yeah, I did already. I did already.
Oh, okay, I didn't see that.
Yeah. I did it really quickly. All right. So enter the way. If we have LL MSS, there are 0 values out of position. We will need 0 swaps. Okay. Let's see. SS LL. We're looking at what? 2 swaps here. 4 values out of position. We'll need 2 swaps. And then we have, let's just go with a crazy SLM. All right, we have 52 values out of position. We will need 26 swaps. So, all right, it's 3 o'clock. So we've gotten to the point where we work it out from a mathematical perspective. We could still do the other one that we spoke about. This is actually the most efficient way of working it out. This is, I think, why they can give the table that says, okay, if you have 500,000 values entered, you need to tell us how many swaps that we need to make. All right. Let me just try it one more time. Let me go LM MS ML SS ML SS. All right, 18 values out of position, we will need 9 swaps. And so if it is that we want to go back and we want to actually code using this method, we can make an attempt to do so. Okay. Any questions before we go?
So this is just from my mind. You could attempt like with one error, because honestly, in my head, I don't know if one well, if one is considered a odd.
With one error?
Yeah. Like if one is considered as an odd number. Because
Right,
it is odd, but you know how sometimes maths kind of
what do
dumb.
you mean, like one out of position?
Yeah, just one out of position. Okay, you know sometimes maths dumb
How
in the
would we get
sense.
one out of position?
You could just do LMLSS. That would be one. LSS. That's one of the position. What is that one of the position?
No, you
That's
would
two.
have 2. Yeah, your minimum would be 2 out of position.
Okay, well, yeah, well then it works on all ends then.
Yeah. Because in this case, LLSSS. Let's see how that will work. There's 0 values out of position. Yeah. And that's because we define the sizes of L's and M's and S's. Now, really and truly, according to the specification of the program, you need to go through and take out all of these printf statements that we put in. And the only output that they're expecting to see is printf %sign the swaps. The way that this should work, is you shouldn't have any printf statements. Okay. And if we were doing it for the competition, it would be like this. Sorry. I print out the words. I put the quote a little too late. So it would be like this. And we know that we need 17 swaps. Any issues here? Any issues
message here on WhatsApp, sir.
Okay. All right. I would still say for your own programming ability, attempt it like this. Attempt it with this. But you notice how when we took the time to go through from where we started to making it a little more orderly, to then making it like as a mathematical rule, it actually became quite easy to program. Or is Mr. Valdez delusional?
To tell you honest truth, I was just shaking, hoping it working. So like I surprised.
You see, you end up surprising yourself.
Honestly, so I sit on for 2 days trying to work this out. If it wasn't for Alexandra, this wasn't happening.
Which is why I encourage you all to collaborate. Because the thing is, going forward now, I'm sure that everybody can come out of this class thinking to themselves, okay, sometimes when I have a problem, I could think it through, and always be trying to figure out if there is an easier way to do this. Agreed? And so you know, you spend more, you know, it's kind of like where they say measure twice, cut once. Thinking it through is measuring twice. So that's just what this subject is about. Now I keep on saying you could have gone the route of doing it with the arrays and counting the actual swaps, eh? That's fine. But you know, from a computing perspective, that's cool. But from a mathematical perspective or a resource perspective, that's not the most efficient way. Because it's easier to work with numbers that you see will follow a rule each time than to actually have computer overhead swapping. All right. So how do we feel at the end of this, seeing the results of it?
I have to practice codes. I don't know why I can't remember these things, but I have to sit down and practice these things.
All right. So more practice needed. I feel, to be fair, and you see again, are you getting me on? I feel, to be fair, are you getting me on a recording saying this? Yeah, but hold one.
Yeah, boy, seriously, my hair, boy, tough.
Yeah, I was now about to say something and I lose my train of thought. I guess it wasn't to be said to you guys, and it would have been a confession on video too, you know.
So you was going to say something about maybe like math, you're not really good at maths or something like that.
Oh yes, yes, yes. I will put up a simpler review assignment. Okay, so I will put up a simpler review assignment. You could still submit this one. I would like to see what some of you all have. We'll get through, but I'll put up a simpler review assignment. So at least
I go in and unsend the first attempt because where that was going was way far, and
oh my
I
God,
feel completely dumb because
no.
I was going on the road of checking like the letter, like checking a letter and then checking the letter in front of it to count the swaps. So like that.
No, but
No,
it might have a.
no, I am fine. I am fine.
I
So that
mean,
no, because then
no,
that would
no,
give it
no.
no, that would give it
I did,
maximum. Like, because
yeah,
that would just keep switching down the line, so it'll just
yeah.
give you it.
At, at,
Yeah,
at, at the very least, you have to, swap. You have to swap with something that will fall into its position unless there is no matching one to fall into its position. If you understand where I'm coming from, which is the step that we did just before we figured out the mathematical approach to it. Follow me? So
yeah. But
you will have
you're still not
you'll have
getting
to
to see
count.
that attempt. I good. You're not getting to see that attempt.
Maybe I'll download it before you have.
So I said, and now that that is depression waiting to happen. Like that will
I
make you
hear.
feel like a failure as a teacher if you see that.
Nah, nah, nah,
Like that'll be equivalent to getting hit with a big stone. Like if you think about it, that it's like on the same level.
nah.
See, you should.
Ah,
I advise against it.
just don't, don't, don't do myself that. Don't do myself that.
Yeah. It's a new year. Don't do yourself that this early.
All right then. All right, no problem. Hey guys, it is 3:07. I went past a little bit. So I know that you all look with people shaking their comment, shaking their head like he has somewhere to be. All right, I'm gonna pause the recording.